All right. Hello, everyone. My name is Nidhi Gupta, and it is my pleasure to welcome you to the webinar on SQL Server Database Modernization hosted by AWS. Migrating SQL Server databases to the cloud is a critical part of a cloud journey and requires planning and architectural considerations. In this session, we will talk about modernizing and cost optimizing Microsoft SQL Server on AWS, including pathways to move to cloud native databases. You will learn the benefit of modernizing and how to get started. So let me introduce you to the speakers from AWS for today's session. We have Yogi Barrett. She's the Principal Solution Architect of Microsoft Platform. Runit Vashisht, he's a Senior Solution Architect for Microsoft Platform. We have Simon Lightstone, Principal Product Manager for Aurora MySQL PostgreSQL. Myself, Nidhi Gupta, and Beatrice Mairezo. We are the Global Windows Modernization GTM Strategy Lead. Please be aware that we will be recording this session and we will share that with you soon, so you don't have to worry about recording it. And also, we would be sending you a quick survey at the end of the session, so we would request you to please fill that out. So, quick overview of the agenda for today's webinar. We will start with a quick introduction about modernization of your Microsoft workload on AWS. We will talk about how to modernize SQL on Linux, using FSx for Windows, using Amazon RDS, and how to modernize SQL Server to Amazon Aurora for PostgreSQL using Babelfish. And we will do the demonstrations to cover all these features. We have a Q&A session open during the entire webinar, so please feel free to post your questions in the chat, and our team will answer them as we go along. We will also be using the remaining time at the end of this session to answer any unaddressed questions. So let's start with the basics of what it means to modernize your Microsoft workload on AWS. And this session will be covered by myself and Beatrice. During this session, we will briefly touch upon what is modernization, talk about typical modernization journey, present to you some of the AWS tools for application and database modernization, and share a case study with experience from the field. So how do we define modernization? Modernization in the context for today's discussion is the process of transforming existing application and infrastructure to a higher value open source or cloud native services. And the main reason why customers need to modernize is that it unlocks new business capabilities. It accelerates their innovation cycle, it reduces the technical debt, and more importantly, it also reduces the total cost of ownership because the customers do not have to end up paying licensing costs for commercial products. Here at AWS, we like to think of modernization as a journey that includes enterprise compute, infrastructure, and architecture patterns, people, and process. It is an operational and governance paradigm shift for maximum resiliency and efficiency so that businesses can innovate faster. So now before we go deeper, when we talk to customers about Microsoft modernization, these are kind of the repeated questions that we have seen. The main one is, why should I modernize my application or database? And for some customers, they want to modernize, but ask, how do I go and get started with modernization? Do you guys have tools that can help me modernize my workloads? Which modernization pathway should I choose? Or should I move to open source and so on? And these are all very great questions that get repeatedly asked to AWS. So from our perspective, to help enable our customers, we have the right products, programs, and the right people to help customers unblock these challenges and to help them accelerate their transformation journey to open source and cloud native services. So let's talk about some of the key challenges our customers face. The first one is a pressure to innovate. What we are actually seeing is that our customers want to deliver features much more faster, and they want to accelerate their innovation, especially in the challenging times such as the case of global pandemic, where customers and all the businesses are moving to digital. Rising and unpredictable cost of licensing software is another key reason. As you may already know, IT organizations face increased pressure to do more with less, and they have legacy infrastructure and application that were actually created as monolith application based on old guard technologies. And some of these kind of technologies were not built with cloud in mind. So these customers are facing challenge to scale their businesses, and they are looking at ways to modernize their application to cloud native services. Obviously, there are other reasons like technical debt and also making sure that the staff has the right skill set to do modernization. So these challenges, such as increasing cost, agility to scale, maintaining security and operational resiliency, can be resolved by modernizing your applications and databases on AWS. Now let's see how our customers can take full advantage of the cloud. There are three main transformations that takes place as customers look to modernize both their legacy Windows applications and databases. The first one is moving the infrastructure from on-premise to cloud infrastructure, which is often referred to as lift and shift or rehosting. It is simply migrating existing application and databases to a cloud server instance. There is no need for code changes, and customer manages the instance configuration, software image, etc. Once you are in the cloud, the second one, the next transformation is around re-platforming the application and databases into a more automated and managed environment. So from an application perspective, that means moving your virtual machines to containers. Containerizing applications will help you develop, maintain, and deploy applications faster and improve portability. So AWS has tools like App2Container to help automate the process of containerizing legacy applications. And on the database side, moving from self-service model to a managed database service like RDS SQL will eliminate the need to do activities such as provisioning, patching, and backups, ultimately freeing up resources for more value-added activities. The third area of transformation to the right is to move from commercial software licensing to open source. As you know, many traditional commercial software vendors have built their businesses around software license agreements that are aimed at locking in customers and using punitive licensing terms to force upgrades and migration. And oftentimes, customer software license fees typically add 20 to 50% of cost on top of equivalent open source options. So refactoring your application and databases to take advantage of open source option can help lower costs, improve performance, and gain access to the latest innovation. And please keep in mind that these areas of transformation can be done progressively in stages or all at once, depending on the application and databases and customers' overall readiness to modernize. Now, when we talk about the modernization journey, and when customers actually think of modernizing their application and databases, they think about modernization from perspective of these three phases. From left to right, the assess, mobilize, and modernize phase. So typically customers start with the assessment phase where they do a discovery that try to understand what application exists and then figure out what is the business case motivation for them to start the modernization project. The assess phase is the beginning of your journey and sets the foundation for a well-planned and executed modernization project. We provide discovery and business case tools free of charge during this phase to get the project launched. After the assess phase, you progress to the mobilize phase, which builds capabilities to operate modernized solution in the cloud. The focus is on developing a landing zone, operational readiness, cloud skills, a strong project plan, and a compelling business for case of a modernization. The mobilize phase prepares you for the modernize phase, where you execute large-scale modernization and cloud operations. After completing the mobilize phase, modernization work can proceed rapidly and efficiently during the last phase, since it builds on the established foundational capabilities where you would do replatforming or refactoring of your application and databases. Each successive completed modernization establishes a full-scale cloud operating model. And as I mentioned, there are several AWS tools and services available for customers to accelerate the modernization stage as well. And we will discuss that in the next slide. So AWS offers several tools to expedite your modernization journey in each stage. So let's look at application modernization first. In the assess stage, Migration Hub strategy recommendation that provides assessment of your application portfolio in an automated manner. Using this tool, you can get recommendations on your modernization pathways. And in the modernize stage, we have porting assistance for .NET that helps refactor old .NET implementation to the latest .NET Core. We have App2Container, which is a command line tool for modernizing .NET and Java applications into containerized application. And if you want to transform a monolithic application into microservices, you can use Microservice Extractor for .NET. And when it comes to database stack, these are some of the tools. I will not be going deeper in this as we'll be covering this later in the session. But briefly, in the assess phase, we have database migration service and schema conversion tool. And in the modernize phase, we have tools such as Replatforming Assistant and Babelfish for Amazon Aurora. And we'll learn about this in the next few minutes. AWS has created a number of offerings to support your modernization journey, to help you go through these modernization projects. When we speak with customers to understand their modernization needs, typically there are three different scenarios we see. The first scenario listed on the far right is where the customers know how to modernize, and they also have staff to do the modernization project. So pretty much they are self-sufficient in undertaking these projects. And these customers typically need some sort of motivation factor to kickstart their projects. We enable these customers looking to offset some of the project costs to accelerate their decision making. The second scenario in the middle is where the customers know how to go about with modernization, but they may not have the people or staff to do that particular project. So they would need some sort of expert guidance whether it's in form of ProServe or partners to actually execute on their modernization project. And the third scenario is where customers want to modernize their application and databases to move to modern technology stack, but they do not know how to do modernization. They do not know how to go about approaching this, and they do not have people to do that work. So they need some sort of coaching methodology to train them on how to modernize their application and databases such that they can become self-sufficient and modernize on their own. So from AWS standpoint, whether you would benefit from expert guidance through partners or ProServe, or you need resource supplementation for putting together a business and technical justification and plan of action, or if you're looking to offset some of the project costs, we are here to help you. So here is a list of some of the competency partners that AWS work with to help customers make decisions to move to cloud. So now I would like to bring you some experience from the field, wherein I would like to invite my colleague Beatrice to review a case study to see how AWS played a role in helping our customers. So welcome, Bea.
Thank you, Nidhi. Hello, everyone. Thank you for having me.
So what are we seeing in the field from a modernization perspective, Bea? Can you share a story where customers achieve their business objective through modernization?
Oh, absolutely, Nidhi. We're seeing an increasing number of customers from a wide range of industries and geographies modernizing their Microsoft workloads to open source or AWS cloud native technologies. And as you mentioned, they may have different business drivers or may have chosen different pathways to modernize. But what they all have in common is that they have achieved their business outcomes by modernizing with AWS. So we're definitely seeing this as a trend in the market. And for today, I'd like to share the story of how we helped the Expedia Group by modernizing their SQL Server workloads to AWS. Yes, so as you may know, Expedia Group has more than 20 reservation sites like Expedia, VRBO, Hotels.com, and Orbitz. And through them, travelers from more than 70 countries reserve their lodging, flights, and other services in more than 80 currencies, catering payments to both consumers and partners. And in 2019, Expedia processed 25% more commercial reservations than in the previous year. However, as the volume grew, jobs took longer to execute, which caused cascading delays to the users and affected the reconciliation of payable accounts. The SQL Server workloads also required a significant amount of manual intervention that impacted the company's operations staff. And because some of the services were created in .NET, an open source developer platform led to vendor lock-in, limiting service deployment. So Expedia deliberately decided to move to a Java microservices-driven architecture supported by the AWS infrastructure that could scale to meet the high traffic and high availability requirements of the system. And after performing analysis and cost comparisons of SQL Server and cloud offerings, the company chose to refactor from SQL Server to Amazon Aurora.
This is very interesting use case, Bea. Thanks for sharing. Can you tell us what benefits they experience?
Oh, yes, definitely needed. So, Aurora eliminates licensing fees and provides flexible cost and infrastructure. Expedia no longer has to spend money on unused capacity in its data centers. This actually enabled them to adapt during the COVID-19 pandemic. And after refactoring the schema from SQL Server to Aurora, the team started migrating components built on the .NET framework to Linux and Spring Boot, the open source Java-based framework. So now Expedia has 20 microservices built on the Spring Boot stack, and the new system uses AWS open source services that not only unify the Expedia payment technology stack, but also eliminate vendor lock-in. It also allows it to scale its services up and down as needed to meet sudden spikes in traffic and high availability requirements. These improvements also enabled Expedia to streamline and simplify its technology stack, resulting in a reduced manual touch rate for processing partner payments from 17% to 0.06%. So using Aurora and more than 20 other services from AWS, Expedia cut costs and enabled staff to focus on the core business by automating manual processes. Expedia also now delivers near real-time data to its users and internal teams, resulting in a streamlined payment process and improved visibility and insights from its supply partners. As bookings come in, the data is delivered to the operations team or vendors in less than 1 second, compared to more than a day through batch processing in the previous server.
Wow, definitely a big win for Expedia and for AWS. Thank you, B, for sharing the story with us. And now we will know a bit more about Microsoft workloads modernization. I will pass it on to Runeet and Yogi to dive deeper into SQL Server modernization on AWS. Thank you, everyone. Passing on to you, Yogi.
Sure. Hello, everyone. Just give me a second. Just trying to share my screen. Okay. It's all good, right, from the screen sharing?
Yes, looks good, Yogi. Thanks.
Okay. All right. So good afternoon, good morning, everyone. If you're in Eastern time zone, good afternoon. If you're in Western, good morning. So my name is Yogi Barot. I'm a Microsoft specialist, principal solution architect at AWS, and part of my role, I help customer migrate their Windows workload to AWS Cloud. Today, we will be talking about SQL Server database modernization options on AWS. So let's first talk about what are the options to deploy SQL Server on AWS. So customer have an option to run a SQL Server on EC2, like rehost. So a lot of time when customer think about migrating their database workload to AWS, three things matter. Number one is like a speed. Number two is like risk, and the number three is innovation, right? So you want to make sure you have a fastest performing database. At the same time, you want to take minimum risk for your database system, and you also want to leverage some innovation. So based on what you decide, we can go with either of the option. So if you are going with the fastest way to migrate in the cloud, so fastest and the lowest risk approach is to go to run your SQL Server on Amazon Elastic Compute Cloud EC2, right? So on EC2, you have a similar experience where you run SQL on premise. You have a full control of operating system. You get all features and versions supported, and you can also bring your license to AWS in terms of EC2. The second option is a lot of customers decide to go modernize their SQL Server database. They run it on Amazon RDS for SQL Server. It's still fairly a low risk approach because at the end you are still using a SQL Server engine, and you are still benefiting from cloud native features like automated patching, automated backups, and HA setup on RDS SQL Server. With customers who has a limitation running their SQL environment on RDS SQL Server because of some feature not available or because of some customization it is required to run their applications such as Microsoft SharePoint. In that case, customer can consider our latest offering, Amazon RDS Custom for SQL Server. With RDS Custom, it's still good of both world. Basically, you still get a managed experience, you still get an automated patching and backups, and at the same time, you have a full control like EC2, and you can run your custom agent or custom software on RDS Custom. So as the name stands, RDS Custom will give you an similar experience in a more open environment, allow you to do more customization. And the last option with a greater risk is to refactor your application. It depends on your use case, right? So I've been DBA for many years, and what I have seen, customer running their SQL Server database, and they're running their applications on SQL Server where it's not even required, right? So sometimes you are just trying to shoehorning a workload, trying to fit into a relational database, but it might not be a best fit for relational database. So for that purpose, we do offer a wide variety of database services like Amazon Aurora for RDS SQL, Amazon Aurora for PostgreSQL, Amazon Aurora for MySQL, and DynamoDB for NoSQL, Neptune, and the TimeStream for time series database. So basically, we have a lot of options to modernize. Again, as I said earlier, the more you go modern, you have to make changes to your application, and then you need to test it out and see how it works. So today, we'll be talking about few of the services out of this, and then we'll see how we can take it towards our modernization journey. To start our journey, the first talk we will be talking about is how to reduce your cost and simplify your SQL Server high availability needs with Amazon FSx. So in this section, we'll talk about SQL Server failover cluster with an Amazon FSx implementation. And we'll also talk about Amazon FSx for NetApp ONTAP, our newer offering, and then we'll summarize the benefit that we'll achieve through this discussions. So what does it look like running your SQL Server high availability on AWS? When you run your SQL Server on EC2, it's exactly similar to run your SQL Server on-premise, but you get more advantage because you have a faster instance like Nitro instance. You get an advantage of variety of instance type that AWS has to offer, and you also get an advantage of having monitoring and management perspective. We have a great sets of tools which are available. You get to use that on AWS. Now let's look from HA point of view. From HA point of view, high availability point of view, you have a couple of options to set up your SQL Server. Like traditionally, I've been using log shipping. It's still supported. But when you say Agile with automated failover, these are the high level 2 solutions that's mainly everyone is looking to implement. So the one is using always on availability group, and another one is using Windows failover cluster with SQL Server failover clustering, right? So always on availability group, we know it's a traditional setup, the way it works at synchronous or asynchronous replica across 2 different nodes. Now, when we talk about Windows failover cluster, a lot of customer might think that might be an old way or legacy way to implement Windows Server failover clustering. But on AWS, we made it in such a way that you can use the latest technology and you can take an advantage of modernization using FCI. So with always on, with failover cluster, with always on, there is no shared storage. With failover cluster, you need to have a shared storage. So with Amazon FSx for Windows File Server, it's a fully managed service for Windows file system, and it's deeply integrated within AWS, and it will provide you a way to have a shared storage for your database service. So what is an FSx? If you look at an FSx, it's fully managed by AWS. So it's a managed service. It provides you to have a multi-AZ deployment, and it's Underneath, it's built on the Windows server, file server, right? So it's fully compatible with Windows file system, and it also have an ability to join to an Active Directory. So that way, basically, you can use it to run your SQL Server. FSx comes in a different throughput and capacity. It's important to know the throughput and capacity requirement for your SQL Server database, especially getting to know your IOPS and throughput. And that way you can configure different throughput capacity for your FSx storage. It starts from 8 megabytes per second up to 2 gig per second throughput and different capacity as well. So let's look at the SQL Server architecture on AWS, right? So as you see here on a diagram, we have a VPC setup. VPC is your private virtual cloud, and within the VPC, it's your own area. You set up your subnet within availability zone. So availability zone in AWS are like multiple data centers, which can be 100 kilometers apart, right? So traditionally, when we talk about high availability, it's a SQL Server up and running on one hardware or one rack of server, or probably it's in the same data center, right? That's the only way you can achieve an high availability, because you don't have another infrastructure where you can have a synchronous replication. But with going to cloud, at least you can take an advantage. Going to AWS, we have an availability zone, which are different data centers, and then you can still get your high availability setup across those data centers. So we have an EC2 instance, and on EC2 instance in one availability zone, we install SQL Server, and we have an EC2 instance in another availability zone where you install SQL Server, right? So, and then we need, when you use an traditional architecture, you have an always on, which using EBS volume. Now, when we look at modernize with FSx, SQL Server FCI with FSx, we have a different architecture. With FSx, because you need a shared storage, we will be using FSx for Windows File Server multi-AC with continuous availability as in shared storage. So we don't need to worry about having any third-party solution or anything for shared storage. We can just use this native service. So this is how your SQL Server FCI with FSx deployment looks like. So on high level, we have, again, same architecture within region, within multiple availability zone, and you have SQL Server installed on one availability zone as a primary replica. On another availability zone, you have SQL Server as a secondary node, right? So how this is configured, you might be looking at how this is configured because it's a shared storage. So FSx is underneath is a file system, which is synchronously replicated using a block level replication to another file system and another availability zone. So that way your share is always available in multiple availability zone. So now when you install your SQL Server in this architecture, you have this FSx share, for example, D drive. You are mapping this D drive as a share on primary server, and you're also mapping the D drive as a share on secondary server. So in case any resources, or in case the server goes down, the cluster fails on a primary server, because you have an secondary setup using Windows failover cluster and SQL Server failover cluster, SQL Server will fail over from your primary instance to secondary instance using SQL Server failover clustering, right? So within seconds, you will get your system up and running on another availability zone. The advantage of using SQL Server FCI with FSx is it supports all addition of SQL Server, right? So with always on, the drawback that you had earlier, that it only works with enterprise edition for multiple databases. Most of the customer have multiple databases, right? So in that case, you can have your SQL Server instance level protection using FCI with FSx. What it means by instance level protection, that means everything on the SQL Server instance, including master database object, the system database object, everything, the jobs, logins, will be replicated to another instance I love this option because I don't need to replicate the logins and restore the logins and set up the jobs on another replica, right? Another advantage of this option is because now this is an instance level replication, you don't need to go for an enterprise edition and pay a high cost of enterprise edition. You can still be fine using a SQL Server Standard Edition and save cost. So with FSX is only an active passive implementation. It's not an active implementation. We can do an active implementation. Actually, I have a blog coming up. I can share the link. I know someone asked a question on the chat. Yeah, we can do an active multi AZ deployment using FSX as well. But what I'm showing over here, this is an active passive deployment where you will have one instance active as a primary and second is completely passive node. It doesn't serve the traffic. So why FCI over always on ability group? As I mentioned, it helps you lower the TCO. So SQL Server licensing point of view, you don't need to pay for enterprise edition license. Again, a lot of customers are already familiar running Windows failover cluster, SQL Server failover cluster on premise. So it's a similar setup for them. It provides you, again, this is also one of my favorite thing, that the reason why it's faster, because in FSX, the replication is done at the storage level, right? So you are not using a SQL Server instance, CPU and memory to handle and do the data transfer. So that way, basically, it takes away the pressure from CPU and memory from the database server, and FSX take care of replicating your storage. So it's a storage level replication rather than transaction level replication. And it's simpler to implement. It's easier. It supports, and with Witness, it supports an automatic failover as well. You can't go wrong. We have a customer using SQL Server FCA with FSX for even if they want sub-milliseconds latency, FSX supports that. It supports up to 3 gig of throughput as well. So to right size your FSX system, what you need to know, this is an important thing. A lot of time I've been asked to troubleshoot a customer implementation where we find that we don't have an right architecture for your FSX. They said, oh, Yogi, my SQL Server, I implemented exactly what I had it on premise, and now I found it's not running optimal, it's running slow. That, you know the reason why? Because on premise they have 10 drives and they replicate the exactly same structure. They had 10 FSX, one with 50 gig, another with 100 gig, another with 200 gig. That's not an optimal way to store your FSX. With FSX, it provides you an IOPS based on gigabyte of storage. So for 1 gigabyte, it gives you 3 IOPS, right? So you have to look at your IOPS and throughputs and then determine an FSX capacity and to right size your FSX, right? So that is an important to find your IOPS and throughputs using disk read per second, disk write per second, Windows Performance Monitor Counter, and you can get your throughput using disk read byte per second and disk write byte per second. Right. So once you get your IOPS and throughputs, then probably I would suggest to, instead of having multiple drives for running multiple folders, just like you have it on premise, I would say have one FSX for data, one FSX for log. Again, it depends on how much of storage you have for your data, how much total size of your database. If it's in terabytes, I would still say even if up to 5, FSX supports up to 64 terabyte, right? So even if it's like 5 terabyte of database, I would still say just create one drive and put all the data over there, and put one drive for logs and put all the logs files over there. So this is another use case, basically SQL Server FCI with FSX with distributed availability group, right? So I had a unique customer requirement, and a lot of customers follow that architecture later on. Basically, they really like this SQL Server FCI with FSX because they did not have to manage so many instances with that, right? So they said, we want to set up a multi-region DR architecture using an SQL Server FCI with an FSX. Is there any way you can do this? Because since SQL Server FCI with FSX requires and synchronous block level replication, and you need and something similar architecture in another region as well, then you need to figure out a way to sync these two architecture, right? So if you use an SQL Server FCI with FSX, what you can do, in one region you can set up your primary, secondary, multi-AZ FSX deployment and install Windows failover cluster, install SQL Server failover cluster on top of it. And same thing in another region, what you can do is you can have a SQL Server failover cluster and Windows failover cluster exactly replicated what you have in another region. Now you might be thinking, how do I sync this to replica? So to syncing this to replica, what I suggest is create a local availability group using a SQL failover cluster name. So when you create an SQL Server always on availability group, you use an SQL Server FCI name, right? Same thing, you'd create an SQL Server local availability group using a SQL FCI name on the secondary region as well. So once you have this setup, you can create a distributed availability group using an asynchronous replication across those local AGs, right? So advantage of this distributed availability group setup using SQL FCI with FSX is you can have both of the domain can be joined to a different Windows domain. So SQL failover cluster 1 can join to an example 1 Active Directory domain, and SQL failover cluster 2 can join to example 2 Active Directory domain. So in either of the case, it is a domain independent architecture, and we are using a certificate based authentication for distributed availability group to make it happen. So this was a unique requirement for the customer, and that was also followed by other customers as well, because it helps you at least instance level protection for your databases, and it gives you a high RPO requirement for multi-region disaster recovery. So let's look at the SQL Server failover cluster versus always on. SQL Server failover cluster is an instance level protection. Always on is a database level protection. For the DR use case, this is a manual effort in case of SQL Server failover cluster, and always on as well, because distributed availability group is always using an asynchronous replication. That's why it's going to be manual failover. But however, you can because this is an async replica, so it depends on how frequently your transactions are getting updated. As soon as it arrives at the secondary replica, you can still achieve a very low RPO. From replication point of view, SQL Server FCI with FSX replicates the entire storage. So for example, you have another engine installed, or if you have even file system or anything stored on that drive, essentially anything on that share is being replicated across another server. With always on availability group, you are only replicating a SQL Server database. So you are not replicating, even within the database, it's only the user database you are replicating. You are not replicating a SQL Server system level objects to it. From scaling point of view, FCI, you can scale up and down your instance. Same thing with always on availability group, you can scale it. Read replicas are not supported SQL FCI with FSX implementation. With always on enterprise edition, you can have read replica. And the asynchronous replication, again, at the DB level, here at the storage level. I would just pause here and see if there is any questions. Yeah, there are a few questions. I would like to answer them. With distributed always on availability group, obviously, yeah, it requires to pay for licensing on SQL Server in another region as well. And if you have a VMC, So the customer you're running a SAN, then if you want to use an FSX to scale using a Fusion IO card on premise, yeah, FSX does not actually support that right now. So the only way for us to do a SQL Server failover cluster using shared storage is using FSX, and we do have another option which I'm going to talk next. Thanks for asking those great questions. So one more thing is you can have SQL Server FCI and always on availability group can be also mixed implemented in one cluster as well. So now let's look at the Amazon FSX for NetApp ONTAP. So customer had requirement to use an NetApp ONTAP, right? So NetApp ONTAP is specifically primary, it's still using the same kind of an SSD storage, and we have a throughput capacity, and it has a, by default, it has a multi-region implementation, right? So when you set up that, it creates an multi-region cluster for your SQL Server. So what I would like to talk here with ONTAP, what's the different? So it's a fully managed, highly reliable, scalable, and future-rich file storage that's built on NetApp's popular ONTAP file system. It uses the multi-protocol. So with SQL Server, we only use SMB, like with FSX was only supporting SMB protocol, versus with ONTAP, NetApp ONTAP, it supports the NFS, SMB, and iSCSI protocol, and it works for Windows as well as Linux system as well, right? So with our SQL Server HA point of view, let's look at why it is different here. So SQL Server always on FCI supports the use of shared storage. Now shared storage can be presented via both SMB and iSCSI as well for using SQL FCI. So you have it's the same architecture basically. You have a primary file server and secondary file server that has spread across two different availability zones. And there is only one key differentiator here with our service that with typical on-premise deployment, customer has an HA pair in close proximity within the same data center. And versus here, we have it across the different data center, right? And another thing is you will have all the tools which are offered by NetApp ONTAP to do the administration and the snapshots and the backups on this. FSX for Windows File Server versus FSX for ONTAP. So let's just walk through some of the difference over here. So with SSD storage, a good thing is you only pay for average amount of storage provision for your file system per month, and it's measured in gigabytes per month. With IOPS, earlier you had 3 IOPS included every gigabyte per storage, right? Capacity pool, throughput pool usage is also different. You have a choice to, with NetApp ONTAP, you can basically move the storage from a lower cost tier. So basically cold data automatically going to an cycle to another cold storage, right? So with FSX for Windows, you don't have an options. It's only one storage tier that you provision, whether it's an HDD or SDD. So we have different options now to hold your SQL Server FCA with FSX workload. So in summary, this is one way to modernize is use an FSX. I have customers with having 100,000 transactions per second. Those customers are using SQL Server FCI deployment with FSX, and they don't have any complaint the way it works, right? So it provides an faster storage, it handles the replication, and it frees up the CPU and memory. That's an advantage. It's very simple to implement. And at the same time, it can help you reduce the TCO by saving the license cost. You can use the SQL Developer Edition for the non-production environment. You can bring your SQL Server license and use the, remember, when you bring your SQL Server license to AWS, you can have, and if you have a software assurance, you can use one passive node free benefit. That means for your primary, you pay for your primary, and your secondary SQL Server license will be free. right? You can also use a optimized vCPU feature and take an advantage of that as well. So with BYOL and pay-as-you-go, you can mix as well. And you can use some of the services like AWS database migration service to move, if you want to basically you might argue that, oh, I want to have a read replica. So if you want to set up a read replica, instead of using always on read replica, you can just use a SQL Standard Edition and have another SQL instance, or you can even have Aurora and then move your data from SQL Server to Aurora or another SQL instance using DMS to provide a readable secondary, right? So this is a great way to save a cost for your SQL Server deployment on FSX with FCI with FSX. Here is the link for more resources and the more documentation. The very detailed blog talk about how to do an HA deployment and best practices for SQL Server documents, and also an FSX for native ONTAP documentation link as well. All right, so now I'm going to pass it on to okay, let's see if there is any question here which I have to answer before I move to the next session. Is there any defined time delay for data replication while doing manual failover for DR? It's a good question. Basically, it depends on how frequently you are replicating your data, right? And how frequently you are making your updates, right? So if you set up an always on availability group, or if you use an SQL Server FCI with distributed availability group, your replicas are always in sync, but those are synced asynchronously. That means every time the transaction happens, it is getting replicated as soon as possible to a secondary region, right? So it can give you minutes of RPO and RTO as well. To answer your question, yeah. So depends on how the way we have created an AWS infrastructure across the region. We have a stronger infrastructure to provide you that RPO and RTO. All right, so let's move to the next topic. For SQL Server on Linux. So in this section, we'll talk about how to modernize using SQL Server on Linux and what are our options, right? So we will also have we'll talk about why to run SQL Server on Linux, and we'll talk about some of the automated deployment tools like AWS Launch Wizard for SQL Server. And we'll also have a demo after this presentation to see running SQL Server on Linux deployment as well, right? So let's just walk through the next topic over here. So why should you even consider thinking about Linux, right? You might be in the same boat as me if you are thinking this question, because when I was a DBA back, I was never thinking to run MySQL on Linux, even though I did a POC when Microsoft announced they are supporting SQL on Linux. The reason why I was hesitating because I was more of a Windows experienced user, and I didn't want to move away from that Windows experience, right? But when we look at from the organization point of view, if you want to eliminate the Windows licensing cost and preserving the customer experience, if you want to have a flexibility of deployment, like different OS for different environment, for example, you can have a Linux environment in development, and if you can have Windows in production as well. Or if you want to migrate from Windows to Linux, we do have some kind of tools also available to assist, right? But basically, the main thing is rapid deployment, slower TCO, and have flexibility. Also, I would like to add and point over here. It's an enterprise-ready system. How many times you see your Windows server rebooted for no reason, and how many times you see your Linux server rebooted? Linux operating system is pretty stable generally, and it helps you SQL Server to be stable as well, right? Also, it provides a seamless AD authentication as well for your for SQL Server deployments. So here you might be thinking how much of cost saving it is, Yogi. You're talking about cost savings, right? So why would even I bother to look at this, right? So for example, when replacing the Windows Server with a lower cost Linux distribution, you could help lower cost without sacrificing performance, enterprise features, and functionalities. So from license perspective, basically for EC2 instance, if you are running EC2 instance, we have different comparison over here. From what we can see, we can save up to 20% of cost between Windows and Linux deployment, right? So if you have a larger SQL Server deployment, that will be an easy win for you to save 20% of your SQL Server cost, right? What else we have about SQL Server on Linux, right? So we have it available in Red Hat Enterprise. We have it available on SUSE Linux and Ubuntu as well, right? You can also, it's not listed over here, but you can also run your SQL Server as a Docker and run it on virtual machine as well, right? So also AWS announced in 2018 that Amazon Linux 2 instance, you can also run your SQL Server on Amazon Linux 2 instance as well. So we do have variety of operating systems within Linux as been supported for your SQL Server workload. So it is enterprise ready. Like we previously talked about setting up an HA, right? So as a customer, you might be thinking, if I go run SQL on Linux, it might be just standalone instance, right? How do I set up my always on availability group and the failover cluster, something that you just described in the previous presentation? Well, we do have a technology called Pacemaker. So Pacemaker was established in 2004, and it's done basically a collaboration between Red Hat and SUSE. So Pacemaker's orchestration, basically it gives you an cluster related activities. So it's kind of an orchestrator which creates and cluster related activities, and it provides you a resource manager. It has an agent, and then just like you have a Windows failover cluster, right? Pacemaker is exactly similar to Microsoft failover cluster manager, right? So with a specific set of agents and SQL Server on Linux configuration, it makes it easy to operate your high available SQL Server on Linux. So Microsoft released the first production-ready version of SQL Server in late 2017, right? So any version which is 2017 and onwards, right? So even subsequent version 2019, the SQL Server is supported on Linux using Pacemaker with an external cluster mode, right? So you have to specify when you create your cluster. This is how basically in simple example of how to deploy your SQL Server 2019 on Red Hat, right? With just simple as 3 line of code. You can just install and then yum install SQL Server, and then you can just set up your SQL Server configuration. So Microsoft provides an Pacemaker resource agent called MS SQL, and this MS SQL resource agent install the MS SQL HA package, and you can configure that for your SQL FCI or always on availability group. It is available from Microsoft SQL Server on Linux repositories. So what are some major advantages other than what we described? So it shares the same common core base, obviously, right? It's a SQL Server. Again, whether it's in Linux, whether it's in Windows, the core common database engine is the same, right? It provides an platform abstraction layer, basically, right? So SQL Server Enterprise Engine, the core feature are OS irrelevant, right? So the core features of database engines are there, right? And we also have a SQL Server, like you can have a SQL Server service also running using a system MD as well, right? So it's kind of giving you a similar database engine experience for your SQL Server. So how do you make it more seamless? Because for a person like me, you might say, oh, I'm not a unique Linux guy. I probably maybe run 10 commands or 20 commands on Linux. That's it. I don't know anything further than that on Linux. So how do you handle that case? So for that, we do have an AWS Launch Wizard for SQL Server. It's an easy deployment of tool that gives you an automated provisioning of the resources based on your requirement, right? So let's look more about Launch Wizard. So Launch Wizard, AWS Launch Wizard is used to deploy your SQL Server for single node or for your HA deployment on EC2. It works for Linux, it works for Windows. It works for always on availability group. It works for SQL Server failover cluster with FCI with FSX. The way it works, it offers you basically you just provide your CPU, memory, and IOPS use requirement, and based on your requirement, it gives you an automated sizing of your SQL instance. It does the configuration and it deploys all the resources on AWS without even need to do any manual provisioning or manual intervention, right? So once you provide all these things, it selects the right EC2 instance, it selects the right even EBS volume type, like go with either IO1 or GP3 or whatever based on your IOPS requirement. And at the good thing is at the end of the deployment, before even you click on the deploy button, it provides you an estimated cost of deployment, right? So you can say, oh my God, I don't want this. This is expensive. Then you can go back and change your IOPS and then look at, oh, how much it's going to be cost now. So it lets you modify your resources to instantly view and update your cost assessment. Right, so once you approve, then you can click on Launch Wizard to create, and it will automatically provisions and configure the resources on your behalf, right? It also, good thing is it also creates a CloudFormation template, right? So I had a customer use case, they had like hundreds of SQL Server, but they are using the same footprint for all of their customers, and they want to create something similar architecture in different VPC and different account for their customers, right? So once they set up their, it's like a cookie cutter, right? Once they set up once you have your recipe ready, you can just use your CloudFormation and then use that to create subsequent deployments and scale your deployment in another accounts as well, right? Also, another thing about Launch Wizard is you don't need to worry about whether I'm using the best practices deployment or not, because it already inherit the AWS Well Architecture Framework, and it adheres to the best practices, and it's optimized for security, reliability, performance, and cost savings, right? So it's a great tool. If you haven't tried, try using Launch Wizards. How much it costs? It's free of cost. You don't have to pay anything for using the tool. You just pay for the underlying resources. So how the Launch Wizard works. So basically you provide a specification like performance, throughput, and networking. In a performance, especially you just say, I need 4-core server, I need 16 gig of memory, I need like 3000 IOPS and maybe 500 megabytes of throughput. That's it. Then Launch Wizard will determine the best instance type, or they can say, oh, you can go to M5 2x large based on your requirement, and then it says, oh, you go with GP3 storage, and it creates an automated specification for you, selects an instance, and then it does an automated deployment of everything, including the VPC, always on like availabilities, creates and subnet within the VPC. It creates an instance, it sets up the security groups, it sets up the firewall, and it makes sure all the things are configured based on your requirement. Installs SQL servers, installs always on, set up the create the always on listener, everything basically does it, make it ready for you. It's also supported for Windows and Linux as well, right? So now it also supports the pacemaker with Windows always on deployment using pacemaker as well. So that will be also good to know as well. And yes, it will also, if you have your supported SQL Server on Linux, right? So for Linux specific, it supports a different Ubuntu 18 with SQL Standard or Enterprise, or RSGel 7.9 with SQL Server Standard or Enterprise. And then you can use custom AMIs for BYOL scenarios. Yeah. So there is a question here, does it support the BYOL? Yes, it does support. So if you have a customer BYOL, it is supported for Launch Wizard as well. So what are the features it provides? We talked about the deployment features, the configuration options, sizing, and estimates, right? So single node deployment, always on AG deployment, FCI with FSX deployment. You can reuse the code template. It also supports the dedicated host as well, actually. So if you are bringing your Windows license, if you are bringing your SQL license, it does support both of that. And it also supports the Windows Server and the Linux support as well, right? This is comparing to Quick Start that we have. With Quick Start, you cannot do all this like BYOL and dedicated host and all the stuff. Basically, with Launch Wizard, it's much better. It gives you an estimates, it gives you the recommendation, and you can just do single click. It does a lot of integration with other tools as well. Like you can integrate with CloudWatch for monitoring. You can create your own managed policy, IAM policy as well. You can also specify which Active Directory to connect. So a lot of input. If you don't specify anything, you can just do the default launch as well. And if you want to customize to specify all the input, you have an option to specify as well, right? So it does have a lot of flexibility in configuration of Launch Wizard. In summary, SQL Server on Linux helps lower TCO. Instead of telling me just helps lower, let me just share an example. So, a customer in Canada last year, they changed their SQL Server on Windows to deployment to SQL Server on Linux deployment. We do have some tools to use that as well. So basically, you can. This customer example, which I'm going, they were just using backup and restore method to migrate their SQL database off from Windows to Linux. At the end of the year, they saved 200,000 just for their SQL Server deployment by moving from Windows to Linux. There is no no other optimizations. Like I can talk about 10 other optimizations to save the cost. But in this customer use case, they only did SQL from running from Windows to Linux, and they saved this much of cost, right? Plus, we have a great tool like Launch Wizard to support the deployment as well. So let's see if there is any more question to answer. If not, I can pass it on to an demo to Runit. There are a few questions. Will Microsoft support SQL Server on Linux if the customer has a premium support agreement for SQL Server support? Yes, Microsoft will. It is a supported configuration, so it will support the SQL on Amazon Linux. Yeah. And another question is, does Launch Wizard work with BYOL? Yes, it does work with the BYOL. You can bring your custom AMI. And there's a next question. If FSX shared storage is not an option for SQL on Linux, that's correct. FSX is, as the name says, Amazon FSX for Windows. It's a shared storage for Windows. If you need a shared storage for Linux, you can use an EFS instead of FSX, right? We do have some sort of shared storage. Right now, we don't have any deployment using SQL FCI on Linux. You can try this with Pacemaker. Pacemaker supports within shared storage using EFS, right? So you can try that deployment. The next question is, SQL Server Express is available on Linux? As there is, yes, absolutely. SQL Server Express is absolutely available on Linux. You can also run SQL Server Developer Edition on Linux as well. And you can also, in fact, I have advised customer to run their non-production on Linux, because you don't go and patch your non-production server. You don't do most of the stuff from Windows point of view. Mainly, you are hosting your database using backup and restore. You take your production database backup, restore to non-production, and you are just running your SQL Server using Management Studio. In that case, yeah, absolutely go for SQL on Linux to save your Windows on EC2 cost and give some great surprise to your management by giving some great optimization techniques. All right, I can see Ronit's sharing the screen, so I'm going to pass to Ronit if there is no more question. Yeah, go ahead, Ronit.
Cool. Thanks, Yogi. Yeah, so Yogi talked about running SQL Server on Linux, and she talked about Launch Wizard and also setting up your own SQL Server on Linux per se directly on EC2. So let's take a quick look. So if you have worked with AWS before this interface will look very familiar. This is called AWS Management Console. And the way you can create your SQL Server instances on EC2 to look at first is you can come to your management console and go to EC2 dashboard either by clicking on EC2 here on the dashboard home, or you can just search for EC2 directly from the search bar. And once the dashboard comes up, it will show you some information about what is currently going on, how many instances are running, etc. But to begin with, you will click on Launch Instance, and it will open up the Launch Wizard. This is the EC2 Launch Wizard, so it just tells you how to, or essentially assist you in setting up your EC2 instances. So if you search for SQL Server, and it will show you all the Amazon Managed Images or AMIs, which can be used to kick off your SQL Server creation. And not a surprise that there are multiple options to set up SQL Server on Windows Server, starting from Windows Server 2009, running SQL Server Enterprise or Standard, so on and so forth. But if you scroll down, you will see some additional options to set up SQL Server on Linux. Yogi mentioned we support SQL Server on Red Hat. We support SQL Server on Ubuntu, on SUSE Linux. We also support SQL Server on Amazon Linux too. Now, the process of setting up SQL Server is you choose your Amazon machine image and you click on Select, and it will then walk you through the different steps which are required to make some selections. So first selection is what kind of EC2 instance do you need, and this is what is going to decide how much vCPUs and corresponding memory that you will get with your instances, as well as whether your instance is EBS optimized and how much network throughput you would get. So based on what your requirements are, you can choose one of the instances. And like in this example, I'm just going to go with one random instance which is in front of me. Now, with the instance type selected, you can click on Configure Instance Details. Oh yeah, by the way, before I forget, for SQL Server, of course, you can filter by families, your instance families. Sorry, I clicked on back button and came back here. So if you're setting up SQL Server, you might like to select memory optimized instance, which in this case could be R5, R5B, etc. And then your instances are then filtered based on your instance family. So yeah, you select your instance type and then click on instance, select instance details. Yes, I want to continue with the new instance type that I've selected. In the next step, it is going to ask you some information about like how many instances do you want to create and what kind of network your instance is going to be in, whether it is going to be in VPC and which VPC it's going to be go in, then subnet. I'm not going to go through all these details, but essentially this is not very different from a typical EC2 instance setup. I'm going to click on next button, which is going to say add storage, and this is where you're going to choose the different storage types that are supported. You can go with the provisioned IOPS, which is IO1, IO2, or you can go with general purpose, which is GP3, the latest one. Now, for databases, provisioned IOPS make sense a lot of time because then you get predictable IO performance from this storage type. But if you're perhaps need GP2, maybe for your dev test, or even in a lot of cases, even for production, GP2 makes sense, then you can go with GP3 instance type. You can select the instance size. Again, this is not the point of this demo anyway, so I'm just going to go with the random 300 size. Then in the next step, you're going to click on add tags. So you can provide tags for instance if required. The last one is security group. Security group is the firewall, which is going to decide what kind of communication will be allowed to your instance. For example, by default, you're going to, if it is going to create a new security group for you, it is going to allow incoming TCP connection port 1433 from everywhere. You may like to not change it and perhaps provide your own IP address only, or you can provide your own CIDR block for the network that you may be using. And that way traffic only from this CIDR block will be allowed in. If you have an existing security group, you can select that and choose that security group from this list. Now, what I've done is, and that's pretty much it. Once you're good with this thing, you're going to click on review and launch. And it's going to, after this step, the wizard is going to go ahead and complete the setup process and create an EC2 instance running SQL Server for you. And for this demo, I have already created a SQL Server on Linux instance. And you can connect to this SQL Server Linux instance from your SSH client. Like, for example, I'm on Windows Terminal here. And from Windows Terminal, I'm already connected to the Linux instance, which is running SQL Server. And I can run netstat tulpn, and I can see all the processes which are currently running. And I can see there's a process called SQL Server, the program name with the PID 2950, listing on port 1433. And for me to now actually start working with the SQL Server, I can install SQL clients on the Linux box if I have, or I can connect to this instance remotely from SSMS. So let me bring up my SQL Server Management Studio. Here is my SQL Server Management Studio, and here I am connected to the same SQL Server instance which is running on Linux. So I expand this one, and you will notice there is this small icon next to my database icon, which shows that this is SQL Server on Linux. But I can, and I can of course look at the list of databases which are running on this machine. So if I bring in new query and run in the command select edit version, let me bump up the font size here as well. You will notice that I am now connected to my SQL Server 2017, which is running on Linux platform, Amazon Linux in this case for this demonstration. But this is like the SQL Server that you have used and you have run in the past. You can run DMVs, you can get information. And not just this, since this is the same SQL Server with a lot of feature parity between SQL Server running on Windows, even if you have an application, like in my case, I have this sample ASP.NET application, which is currently connected to a local instance of SQL Server. For me to start working with SQL Server on Linux, all I have to do is, rather than using the local instance of SQL Server running on Windows, all I have to do is point my application to SQL Server running on Linux. So I have to modify my connection string, update the credentials, and that's pretty much it. If I run the application after modifying the connection string, it is going to start using SQL Server on Linux. So from usage perspective and from future perspective, my experience as a developer working with SQL Server running on Linux is not going to be very different than the way I'm running with or using SQL Server on Windows. So that was EC2. Now let's take a quick look at Launch Wizard. Now, Yogi mentioned that Launch Wizard simplifies a lot of steps of setting up SQL Server, especially the complex setup, which involves high availability across multiple availability zones. And you can do that yourself as well. You can, of course, set up multiple SQL Server instances, EC2 instances, just the way I just did using EC2 Wizard. Or what you can do is you can leverage a service called AWS Launch Wizard. And to work with AWS Launch Wizard, of course, you can search for Launch Wizard from the search box, or you can launch the Launch Wizard from AWS Management Console as well. So to get started, you have to click on Launch Application. And Launch Wizard supports multiple applications, not just SQL Server. For example, it can assist you in setting up SAP across multiple availability zones or following the best practices. So in our case, it's going to be SQL Server. So I'm going to select SQL Server and click on Create Deployment. To begin with, Launch Wizard is going to create an IAM role on your behalf, which will be used to communicate with other AWS services like provisioning EC2 instances and provisioning storage for those EC2 instances. So that's the first screen where it tells you which IAM role will be created. If I click on next, I have to make a couple of selections. That is, am I going to create a SQL Server HA highly available option on Windows, or other operating systems that we support are Ubuntu and Red Hat Linux. So in this case, let me just go ahead with Ubuntu. Now you can choose to create a standalone instance just the way I just showed you directly from EC2 console as well. If you want that, you can choose a single instance, Or if your goal is to set up HA deployment, you'll go with the high availability options. You're going to give it a name like SQL HA Linux if this is going to be the name of your deployment to be recognizable from Launch Wizard. Launch Wizard uses SNS topic to generate any notifications regarding your deployment. If your deployment it fails, or if it succeeds, or if there are any issues, it is going to generate notifications, and for that you have to select one of the SNS notifications. Okay, I think I have something with the same name. Now, because it is going to create EC2 instances at the end of the day, you can securely connect to those EC2 instances if required using KeyPair, and that is the option that we have to provide in the next step. If you have an existing VPC and you want this setup to go in that VPC, you can select the option to select virtual private cloud, or if you want Launch Wizard to create the whole VPC, create subnets, it is going to create one public subnet and 3 private subnets to distribute all the instances across multiple availability zones and subnets. And it is going to follow best practices of securing a private subnet so there is no incoming traffic, but at the same time, it requires outgoing traffic going on and the traffic to communicate between the subnets. So either you can make sure that you have all of that set up. If you're not sure how to set it up, you can go with the other option, which says create new VPC. And this way it is going to create VPC on all the required subnets as well. The next one is SQL Server specific configuration for the SC user. What is the password that it is going to use? So you can provide a secure password here. Then the next one is what kind of media or what kind of images will be used to create the instances. If you're going with license included instances, then of course the license included AMIs make sense. I think somebody asked a question that can you do BYOL? You can do, and for that you need to have custom AMIs. I don't think I have any custom AMI. Well, I do, but none of these have SQL Server on it. But you'll have to make sure that you have the right media AMI with SQL Server already baked in, which can be used for the deployment for the next steps. In my case, I'm just going to go with use media included AMIs. And this is where you have an option to go between Ubuntu on Enterprise with SQL Server Enterprise, I'm sorry, or Ubuntu with SQL Server 2019 Standard Edition. The next is the pacemaker cluster name. So you have to provide your name of your pacemaker cluster, and then again the password for that cluster for user HA cluster. So again, give it a strong password. Then the SQL Server user, which will be used to communicate with pacemaker cluster. So you need to give you have to provide a name which can be used to create a SQL user, and password for this user as well. So this is a user that will be created as cluster is set up. Then you need to have an S3 bucket, which will be used to share certificates, and that bucket need to have specific suffix, which should be Launch Wizard. So let me just look up. I think I have one S3 bucket. Yeah, I think this is the bucket that I want to use. In my case, I just called it Launch Wizard -setup -pdx/SQL. You need to have Launch Wizard as a suffix. That's a requirement. Anything after that is optional, or the way you want to put it, it does not matter. The next one is what kind of infrastructure will be used. The wizard is giving you some suggestion that it is going to create 4 instances, and network performance is going to be up to 10 GB, minimum 8 GB RAM, solid state devices of up to 250 GB, and it has pegged instances like C6A extra large with GP2 with specific volume sizes. Now you don't have to exactly go with these recommendations. These are suggestive in nature, so you can, if you want to provide your own instance type, you can select the second option and provide your own instance types as well. right? Since this is a demo, in my case, I'm okay with these suggestions as well. I'm not going to create this cluster anyways because it's going to take some time, but I just want to show you all the steps. Then it tells you what will be the size of temporary database, size of your data volumes, and size of your backup volumes as well. Again, tagging is best practice. It's recommended to make sure that you have right tagging. Again, it's a separate topic in itself. Then you get an overall estimate that how much will it cost you to run this cluster of 4 instances of this particular instance type and storage. You can go back and modify your instance type and instance selection, and based on your selection, you will see these numbers are changing. Like I went from C5A, I think extra large instance, yeah, extra large instance to 12x large instance, and you see my cost has gone up to 17,000 just by changing the size. So this is very important that you should know what you are getting into and how much it is going to cost, and you have the knobs to turn back and modify and then make the right selections. Once this is done, you can click on next. It's going to give you the summary of whatever it is going to create for you. You can go to the summary, make changes if required, and in the end, you can click on deploy. And what's going to happen is, again, I'm not going to do deploy here because I have already done a deployment. So let me just cancel out from here and show you an existing deployment. So I'm going to go back in the launch wizard, and you will see I deployed a cluster again with a similar name, SQL HA Linux. If I select on this and go to configuration summary, I will see what configuration was provided, what availability zones are in question, are being used, what users is being created. And if I want to see all the deployment events, what happened during the setup process, you will see all the steps that it has gone through. Again, what is configured, you can start interacting with your HA cluster in the same way. You can connect to it from SQL Server Management Studio. If you want your applications to start consuming it, you can start using the virtual name and point your connection string to start consuming the SQL Server as well. That was a quick demo. Happy to take any questions on the side. And the best interest of time, I'm going to hand it back to Yogi, who is going to talk about the next topic. But if you have any questions, post it in the question tab, and let me respond to those questions directly there. Thank you.
Great, thanks Ronit for the nice demo. Hopefully now you got an idea of running SQL on Linux and Launch Wizard. So next presentation we'll talk about RDS for SQL Server. So what is an RDS for SQL Server? It's a relational database service. It's a managed service, allows DBA to easily administer and highly scale and automated computing scaling the storage and compute with no application downtime, right? At the same time, it provides you an faster and secure storage for your database. So these slides give you basically a sense of the value of an RDS. As you see here on the left, what you have is your self-managed database on premise. On the middle, you have a database on EC2 where AWS takes care of things in green, like operating system installations, server maintenance, all the stuff. And on the rightmost side, you can see everything in green is managed by AWS. So basically, it frees up DBA's time for doing all these things, which is like tedious OS and database patching and management, and you can focus on more of your innovations. We do have an RDS custom as well, right? So with RDS customs now, you have an flexibility to bring allow all the customization which were missing from RDS. If you have any of the requirement to basically have a SQL Server agent installed, or if you have any other agent installed, if you want to have some kind of an OS patching or database patching to be done by yourself, or if you have say example need to RDP and do some kind of custom parameter configuration. So with RDS customs, it overcomes the limitation of Amazon RDS for SQL Server, and it allows you lift and shift, make it easier to a managed service. So it gives you good of both worlds, basically. Let's look at from the different features and additions and the version point of view, and what is your responsibility and what's AWS responsibility, right? As you see here on the left is an IDS for SQL Server. We want customer to consider IDS for SQL Server first because it's taking care of heavy lifting and you can focus on optimization and performance tuning. While on the right, you can see a SQL Server on EC2. It's a self-managed service, and you can do self-managed HA. You can set up replication or mirroring, always on, log shipping, whatever you want. The disadvantage of it, you see things in the white, it's all managed by you. So basically, you manage the backups and patching and all the stuff yourself. Now let's compare the difference between IDS and IDS Custom. As we see here on the left side, IDS Custom is an about choice or option to apply and granular control over the OS and the database. So there are a couple of interesting points here. So for example, IDS Custom does not require an option and parameter group because you already have a sysadmin right to SQL Server. You can make a configuration changes such as like XP command shell, something like that. So whatever you did not had with IDS SQL Server, you might see as a limitation or stop you from moving towards a managed service in IDS Custom, now you can have it, right? So basically those kind of things from options and the futures point of view, you can install the third-party applications on database server. So this slide talks about the comparison between the different options for your SQL Server, whether you run on EC2, whether you run on IDS Custom or run on IDS SQL Server. Let's just pause here, talk about the version point of view. Every versions, including SQL 2000, 2005, 2008, and 2022 when it's out, will be supported on EC2. For IDS Custom, right now it's only available for 2019, the latest version, and SQL Server, IDS for SQL Server is available for 2012 and up version. Keep in mind, July 12 of this year, yes, it's just 1 month away, where SQL 2012 will be an end of support, and you won't be able to stood up your IDS SQL Server for 2012 instance. For additions, IDS supports Express Web Standard and Enterprise Edition. It does not support Developer Edition, and IDS Custom supports the Web Standard and Enterprise Edition. With SQL Server on EC2, it supports all editions. From HA point of view, it's AWS managed HA for Amazon IDS. I've been DBA for 22 years, and the most challenging part I see is to set up that HA high availability and making sure your replicas are in sync and those transactions are applied at another site and they are not breaking and all these things. Basically, your backups are taken care and the disk space does not run out of space. So with IDS, all of things you don't need to worry about it. It supports with just single click, it supports AWS managed SA. We'll talk through more about this using an animation. Everything else, I think we talked about this as well. One point here is database limitation. With IDS SQL Server, it has 100 database supported up to 100 database. With IDS Custom, you can go up to 5,000 databases. With SQL Server on EC2, there is no limit. You can go up to the maximum for the SQL Edition has to offer. And with operating system access with IDS SQL Server, it's not supported. With all other options, it's you get an RDP access to the operating system. So when customer decided to migrate, this is the timeline basically when we have a lot of tools to help you in each stage. I'm not going through the detail, but I will go to the stage where we can look at the assessment and determine whether IDS or IDS Custom will be requirement for your workload. So basically, when evaluating a different SQL Server options, it's important to do an apple-to-apple comparison across the services, right? So IDS SQL Server offers the license included model, right? And therefore, you are comparing total cost of with RDS versus EC2. You need to keep in mind that you are also paying for license versus SQL Server on EC2. If you have a software assurance, you can bring your license to shared tenancy. If you don't have software assurance, you can still bring your license to EC2 on dedicated host. What else we have seen here is when we do so depends on a use case, right? So the leftmost, if you want to bring your license, you run on SQL on EC2, right? And if you want to get license included, then you will see an RDS SQL Server. Probably when you start looking, you might see it's a very high cost. But when we do an optimizing and right sizing exercise, that's where you see it even reduce the cost. And when we apply the discount and the credits available, it even further reduce the cost as well. So what is this right sizing exercise? We call it as an OLA. OLA is an optimizing and licensing assessment. And OLA for database is basically, it helps you understand your complex SQL footprint and licensing scenario, and it gives you a best migration path to AWS, right? So it analyzes the existing AWS partner licensing subject matter expert. They analyze that with a deep SQL Server licensing expertise. They look at your workload assessment and they do the right size recommendation, and also at the same time it will give you a different option to deploy your SQL Server on AWS. Generally, what I have found with running OLA, customer can save at least 30% to 60% of the cost based on what they select for their destination. So let's look at the reliability, HA, security, monitoring, and configuration for RDS SQL Server. Automated backup with RDS, you can have an automated backup and backups can be there, stay for 35 days of maximum retention. If you need more backups to be stayed longer, you can take a manual backup or manual snapshot. Manual snapshot does not expire, it stays there until you delete it. So manual snapshot, it's triggered by customer. You can do using an CLI, or you can do using an console as well, and then it doesn't subject to any of the retention, so you can keep as long as you want. And the third backup option, and this is the most important backup option because a lot of customer ask for it, is backup and restore directly to S3. So RDS supports and backup and restore to native S3 bucket, right? So basically, once you enable the option, you can do full differential backup and restore from S3 bucket. We do have an AWS backup service that you can take an advantage and back up your RDS using the backup service as well. Now let's look at the multi-easy deployment of RDS, right? So this is what I'm more passionate about talking about RDS. So with multi-easy deployment, this is how it works. As you see here, you have RDS SQL Server primary in one availability zone, and you have application servers in 3 AZs connected to this one database server. Now, when you click multi-AZ, it's gonna do what it's gonna do is have a secondary server set up in another availability zone and create a synchronous replication between those servers using always on or mirroring technology. And these replicas are synchronized, right? So the way it's synchronized is basically it uses an EBS volume and it does an SQL Server replication. And both EBS volumes are in sync using that SQL Server transactional SQL Server always on replication. So now in multi-easy scenario, a lot of customer ask, how does it works exactly in case of RDS if my secondary goes down, right? So let's say, assume your secondary went down here, right? So if your secondary failed, AWS monitoring will acknowledge that your secondary failed. And what it will do, it create a new secondary and it will sync up again, right? So it will make sure your RPO and RTO are intact, right? So it will right away create a new secondary and your databases will be in sync again on the new secondary. Now, what happens when primary failures, right? So let's just see what happens when primary fails. So here in an example, your primary failed and your application were pointing to that primary server. because we have this automated failover setup, your application will be automatically redirected to a secondary which is already in sync, right? And after that, what's going to happen? You won't be run without an HA, because obviously you need to have an HA as well, right? So we'll create a new secondary into the same observability zone as a primary, and we make sure we does a synchronous replication to this new secondary, and we replicate the same synchronous always on replication for your primary to secondary in the new AZ. So now you have your SQL Server up and ready for your primary, original primary AZ as well, right? So this is how it works. Depends on RPO and RTO. RDS SQL Server has different options for HADR feature, right? So multi-AZ gives you 0 RPO, and it's going to take 10 seconds to 60 seconds for the recovery time. If you want to do hours of RPO and 30 minutes of RTO, you can go with a snapshot restore. You don't need even multi-AZ. If you have a minutes of RPO and the 30 minutes of recovery time, then you can also go with a point-in-time restore with the snapshot. And if you have minutes of RPO and less than 5 minutes of RTO, then you can go with a read replica promotion in regional. And if you want to have minutes or minutes to hours of RPO RTO, then you can also create a logical replica promotion as well. So these are the different HADR options. Depends on your RPO RTO. We do have cases to cover each of your deployment option. Now let's look at the deployment point of view. As we looked at the SQL Server Launch Wizard, always Amazon Launch Wizard, right? For SQL Server that supports SQL on EC2. How about IDS SQL Server? IDS SQL Server, we can have a management of SQL Server using SQL Management Studio. You can use SQL command, and you can use SQL Server CLI. With RDS SQL Server, it doesn't need to provision that much, because it's something similar to Launch Wizard already. You can go through the console and you can launch your RDS right away. What is limitation of RDS SQL Server? It supports only up to 100 database, and it does not support currently the database maintenance plan. Also, good thing about IDS is it supports the SQL Server analysis service, integration service, and reporting service as well for your database workload. Now let's talk about migration. This is just a heavy loaded slide. I'm not going to go through all the options. Basically, you can do backup restore. That's number one, because it's a number one option that a lot of customer uses it. The second option is you can use export import. You can use DMS. You can use third party tool, and you can use a SQL Server transaction replication as well. You can also use a log shipping. I just have recently created a script using a custom log shipping for migrating your SQL Server on-premise to RDS SQL Server on using a PowerShell, right? So that script will take all your database and migrate using log shipping method as well. So yeah, we have a lot of options for migration. And just looking at the time, without further delay, I'm going to pass it back to Runit for doing some demo.
Well, let me take over, Yogi. And I see there are a couple of questions in case you want to take a look at these.
I can answer the question, no problem. Yeah.
Awesome, thanks. All right. So Yogi talked about RDS SQL Server. Let's see how you can set up an RDS SQL Server instance. The way you can go about it is, again, back in AWS Management Console, you can search for RDS, and that will bring you to RDS console, which looks something like this. And to get started, you can click on Create Database. And once you click on Create Database, you have option to go with different engines under the RDS umbrella. And for this session, we're talking about Microsoft SQL Server first. So you'll select SQL Server, then is it going to be RDS or RDS custom? So based on what you're trying to do. For now, I want to show you setting up Amazon RDS. So with that selection, you can choose between various different editions of SQL Server. Like, for example, the 4 editions we support are Express, Web, Standard, and Enterprise. With Standard and Enterprise, we support multi-AZ deployments, which means high availability, which can come which can be very important for production environments. So once you select your database edition, the next thing you have to select is what is a version of database that you want to install. And currently we support all the way from SQL Server 2014 till SQL Server 2019. With the database version selected, next is, are you planning to install multi-AZ production deployment, or is it going to be used for test dev, which means a standalone instance might be insufficient and might suffice your requirement. With the production setting option selected, next is you have to provide your database identifier. Think of this like the virtual name for your cluster, the one which will be used to connect to from SSMS or from your application. So you can provide your cluster name here, alias. Then one master username and corresponding password. That's the second thing you have to provide. Then again, you have to provide what will be the instance size that will be used to provision this instance for you. You can choose between standard instances, and from the drop down, you get to select one of the standard instance types. For each instance, you can see the amount of vCPU and the RAM that comes along with it. For databases like SQL Server, it makes a lot of sense to go with memory optimized instances, the R classes or X classes. And when you choose that, you get to select between these instances. If you're doing a dev test deployment, you can also choose burstable class instances. These are the instances which don't provide you 100% of the CPU all the time. They provide you baseline CPU and anything below that. And if you don't consume CPU up to the baseline, then your credits are accumulated. So this is a great use case for dev test environments where you know you're not going to consume 100% of CPU. Like in this case, I'm just going to go with the burstable instance type. Yeah, you can also look at previous generation classes, and if you have a requirement to create this cluster using one of the old EC2 instance types, or sorry, RDS instance types. Then comes the storage. Just like with EC2, you get to choose what kind of storage do you want to provision. By default, it's going to select provisioned IOPS, but if you think that general purpose SSDs make sense for you, you can choose that as well. Now, you can start with allocated storage size, which could be as less as 20 GB, and it could be as high as 16 terabytes. That's the maximum size we support. Since this is a provisioned IOPS, the next thing you will get to select is how much predictable IOPS do you want at all the times. And you can have something as less as 1,000 IOPS to as high as 64,000 IOPS available to you dedicatedly. Now, storage is auto-scalable, which means that you can start with something small and go with an option to enable storage auto-scaling. You can choose your storage to be auto-scaled to a specific size only, which means you can choose that not to go beyond as less as 22 GB and as high as the top limit, which is 16 terabytes. This way, as your data grows, as your data files grow, RDS is going to auto-scale the storage to accommodate that, which means you don't have to provision for the max capacity to begin with. This is something which can scale on the fly as well. Next one is auto-scaling, multi-AZ, which is high availability. And since we have gone with an option of production environment, we get to choose that do we want to go with multi-AZ or not. And that's where high availability and automatic failover comes in, which Yogi just mentioned about. And multi-AZ is highly recommended for any production environment, and that way you will have 2 instances of SQL Server provision for one cluster to begin with. And if you're going with our SQL Server Enterprise Edition, you can even create more instances for your read replicas as well. But for standard, you get to select multi-AZ deployment, and you get to select the VPC in which it is going to go and the subnet group that it is going to go in. Now, you can choose to make this RDS instance publicly available, which means this can be technically accessed over the internet. Again, not a great practice. Hence, it is recommended to choose no, so that your instance can be accessed, or your RDS instance can be accessed from within the VPC only, the VPC which was mentioned here. You can control even within the VPC which IP addresses are allowed to connect to this instance. And for that, you have to select your security groups. You can choose an existing security group if you already have a security group, or you can create new. By default, it supports SQL authentication only, but you can enable Windows authentication on your RDS instance. And for that, you have to enable SQL Server Windows authentication, and that will prompt you to provide your Active Directory instance name. Manage AD is the one which is supported with RDS SQL Server. There are some additional configuration, but this is like the bare minimum that you need, and you will have to click on Create Database. Once you click on Create Database, it's going to take some time, and after that, an RDS instance for SQL Server will get prepared. You will see some information like this, which will tell you whether your instance, what is the instance status. You have to wait till your instance becomes available. I have one instance which is of Web Edition, which I already provisioned. And when you look at the this instance information, you'll see more information which is around connectivity. What is the endpoint that you can connect with?
That's a good thing, Runit. You showed that we had questions about this endpoint. And I'm just looking at the time, we might have to end the demo. I think we covered the RDS creation part, and maybe we can pass it on to the next presenter.
Yeah, let's do that. And that's pretty much it. Now you have the endpoint. Port number is 1433. Now you can connect to this endpoint from SSMS or from your application, just the way you would typically do with any other SQL Server instance. With that, I will hand it over to Simon to talk about Aurora and Babelfish for Aurora Postgres.
Hi, everyone. Can you hear me?
Yep, loud and clear.
Okay. I'm super excited to present Babelfish. Give me a moment to just pull up my presentation.
Sounds good, Simon. Thank you.
Let's see. Can everyone see my screen?
Yep.
Great. Okay, so I'm going to present Babelfish. I'm also going to give a quick introduction to Amazon Aurora. Before I do that, I'm just going to explain what Babelfish is. In a nutshell, and we're going to dive into this in terms of the details, Babelfish allows Amazon Aurora to understand the SQL Server dialect. Now, what is Amazon Aurora? It's essentially almost like an enterprise-grade Postgres managed service. So it's very easy to set up. It's managed for you, on RDS, and it's really designed for scalability. And we're going to talk a bit about that architecture. So why Babelfish is really interesting is that it allows you to take the Amazon Aurora engine or the Postgres engine. Babelfish is in fact open source, so it'll run on any Postgres version. In this case, we're going to talk mostly about the Aurora Postgres engine, and it lets it understand the SQL Server dialect, which means that you don't have to do very much to move your app from SQL Server to Postgres, because the Babelfish capability gives you this TDS port you can connect to and just run your apps. So I'm going to dive in here, and we're going to talk a bit about both Aurora, just very briefly, and then Babelfish. So first, let's just talk about Aurora, which is the engine used by Babelfish. It's very much designed to be high performance, have very high availability. It was re-engineered in the age of cloud. Just double checking, all the attendees are they able to see this, correct? I haven't clicked the start broadcast button. Double checking, we're good to go.
Yeah, I think they should be. I think broadcast has been on for some time.
Great, awesome. Double checking because I got this really handy dandy prompt from the GoToMeeting software. All right, so it's very simple, it's cost effective, and it's drop-in compatible with either MySQL or Postgres. Now keep in mind, if you want to use Babelfish, then you've got to use the Postgres edition of Aurora. Also, it has simple pay-as-you-go pricing. So again, you can even try it for a few hours. It's totally up to you. Now, what makes it, a really great cloud-first database? Essentially, Aurora is a structured log, which means that it's very, very fast for things like writing. It means that there's very little overheads in terms of a write-ahead log. You have everything distributed from the get-go. So basically, that log is written to shared storage, as you can see here. And then on top of that shared storage, you're going to have instances, right, in multiple availability zones available, right? Of course, there's going to be one primary instance, which is read-write, and then you can create more, which we'll see in the following pages, which can be available for your read workloads. I want to mention that, I'm going to give you a basic overview of Aurora. There are features like global database, which will allow more complicated configurations, which may be something you want based on your availability requirements. But I'm going to start with sort of what you get out of the box with Aurora. So again, this means you have 6 copies of your data and 2 copies in each availability zone. And basically all you need is 4 of 6 of those to have quorum and have write availability. So you're going to have a cluster endpoint, which is going to be your writer, and then you can create a whole bunch of readers very, very easily. Because again, all those readers do, they're near instantly available because they're simply attaching to the shared storage fleet. So you can create as many readers, up to 15 promotable read replicas, and you can put those in whatever AZs you'd like. And again, I want to say, a lot of people say, hey, well, what if I want something in another region? Again, look up Aurora Global Database. I'm trying to keep it a bit simple for this presentation, but there's quite a few capabilities there as well. So you have a very, very low replica lag. And again, you can decide how you want to use these for load balancing and failover. So that's a little bit about Aurora, and I think you can understand, in a way, it's a very web optimized, in a way, simple architecture that really scales tremendously. Today, when Aurora was designed, they thought about considerations like, hey, databases are just bigger now. Aurora, even from day one, scaled to about 60 terabytes, and now I believe it can do even more. People are going to have bottlenecks in terms of write speed, so it's designed to help address that. All these things are what goes right into the DNA of Aurora in order to make sure that it's a great fit for the new age of workloads. So some reasons to migrate to Aurora, probably using Babelfish, but even if you do a manual migration, first of all, it's costly to have proprietary licenses. You're locked in. Aurora is open source. Even Babelfish is open source, so you could run Babelfish on your own servers or go to another cloud if you want to later. There's no punitive licensing. Often there's a lot of challenges that we hear from customers, in terms of audits. And also just lets you modernize it, makes it, obviously you can see you can rapidly deploy read-only clones, lets you go global very quickly, lets you build modern applications. It'll increase your agility and staff productivity, especially because when you're running on open source software, you never have to worry about, small projects consuming a lot of budget. You can run them on open source or internally or on small servers until you really get to that scale. And of course, there's a lot of integrations with AI, ML, and overall your digital transformation gets a lot easier with Aurora. Now, there is a problem. It's a bit tricky getting from these commercial databases to open source. And the reason is there's essentially 3 really big challenges. One is you have to rewrite all your T-SQL. That's not just your standard or somewhat standard SQL Server language, but the actual T-SQL language that SQL Server has. The next is you have to rewrite your app code. Well, some of that can be ported over because you may have, abstraction layer, right? Like there's a lot of different things you could do to abstract your database, and that's often done. Still, very often you have to rewrite a lot of code because, especially when you're thinking about things like the .NET framework and the Entity framework, you're going to have a lot of dependencies on SQL Server. And finally, you have to switch drivers, and that might not seem like a big deal, but as soon as you switch out those drivers, it means you're probably also, going to have to rewrite your app code and look at a lot of things in terms of behaviors. We're going to dive a bit deep into that and how that can be a little trickier than you think. So obviously it makes it a little hard to rewrite your application. And that's why we created Babelfish. Babelfish allows you to run SQL Server applications on Postgres with little to no code changes. I would say more accurately, to make sure that you're understanding, there will be definitely some time commitment in terms of rewriting your code, but you're going to be migrating in a fraction of the time compared to, say, a traditional migration with SET, because you can keep your existing queries. You just have a lower risk to the whole migration because it's less work and it will be done in a smaller amount of time. And then once it is done, you're free to innovate. You can continue writing in T-SQL and sort of live in the SQL Server world, or you can start spinning off microservices using Postgres, right? It's really up to you. And I want to say that, frankly, many companies, especially bigger companies, they just have so much T-SQL, they're going to be using T-SQL for a very long time. And really, it's only with new parts of their app that they might consider making microservices in Postgres. Or some just decide to not continue to Postgres and stay in T-SQL for now, with the long-term plan to increase agility, building up microservices. But in some cases, that could be far down the road. It's really up to you. There's no time limit for Babelfish. You can use it as long as you want. We do feel that ultimately, Postgres is better for developer agility. So in the long term, you should be thinking about that and have your sort of operational arrow towards eventually getting into Postgres. But there's no time limit whatsoever. And of course, with these apps that we see on Babelfish, they're just huge, and it's unlikely that they're going to be rewriting all of it to Postgres. Now, I want to, before I go to this slide, actually, I just want to say that you should evaluate, and we're going to talk about in this presentation, how you can choose between a sort of a traditional migration using SCT and Babelfish. And the reason, I'm just going to set a bit of a timer here. There. And the reason that I want to cover that is, there are some cases where Babelfish isn't the ideal situation. For example, today Babelfish doesn't support XML, and in that case, you might want to evaluate an SCT migration to see if that will be a better fit. So keep in mind, Babelfish isn't a kill-all. Babelfish is often the best path, but always make sure that you think about the pros and cons, and we're going to talk about those as we go on. So again, getting started with Babelfish is super easy. Just go to the console, deploy a cluster using the wizard, and you'll see this handy dandy option, turn on Babelfish. One other thing you should do, and then after that you can connect with SSMS. I'm going to cover that in another slide. Another thing is when you get started, just remember to choose the very latest version of Aurora. That's super important because the latest version has the best support for SSMS and SQL Server features, and hence, if you don't choose the very latest version, whether that's 13.7 or the upcoming rollout of 14, then you're going to just get less bang for your buck. You're not going to get as much integration with SSMS and all your favorite tools. So what does Babelfish look like? A lot of people say, well, I don't get it. Is there one port where we all connect? Well, not quite. We actually create a whole new port. So, you have Postgres, the default port is 5432, right? And if you're going through Postgres, you can go through that and see your Postgres database. With Babelfish, we create a new port running the TDS protocol on 1433. And that's how it works. You don't need to change your drivers. And again, there's no like translation layer or anything. Really, we have another sort of interpreter on top of the engine, in addition to the PL SQL, and that interpreter natively speaks the TSQL language and the TDS protocol, right? So it's not like we're doing string replacements. It's a separate port which has that semantically correct understanding of the SQL Server dialect. That also means that inside one app, you can very easily, it's quite common that you'll have two connection objects. One connection object will be, a T-SQL or TDS port, a TDS connection object, and you'll be able to say, use that, and then you'll have another connection object in your code in the same app for your Postgres driver, right? So again, you'll probably have two different connection objects for both if you choose to mix. And we're going to talk about some limitations there later, but in some, that's just so you can understand, how will I both have maybe some Postgres and some SQL Server? What will that look like in code? You're just going to have two connection objects, one for each. And what you could do, for example, is you could, there are some limits I'll talk about because think about it, triggers and stuff, but you could insert, into a table through the Postgres driver and then read that from the SQL Server driver, right? So that's some of the things that you can do in terms of interoperability. In terms of the design tenets of Babelfish, there are three important principles to keep in mind. First of all, there's no compromises on correctness. Database calls will either work or return an error. So suppose we don't support an optional parameter, we will return an error. Suppose there is a difference in precision, we'll always make sure that that precision is returned. And this is important because other attempts, by other vendors at sort of emulation or other, would often sort of just call the Postgres equivalent, not really worry about the return type, and then you'd have a lot of issues there in terms of maybe that's decimal precision or the data type would be returned as a string when it shouldn't be. We really focus on correctness for Babelfish. So if the call does work, it will return what's correct. And if we can't return the correct type, then we're just going to return an error, and you'll find that as an error in your code. The next is wire protocol compatibility, and that means that you're going to be able to work without changing your drivers. And while that might not seem like a big deal, changing your drivers, it's one of those things that, hey, wait a minute, I changed my driver, now I have to start really rewriting all my code. As long as we keep that driver the same, that sort of, ensures that your code is going to have very few changes required, right? Because it's communicating using the same driver. And finally, interoperability. That's just the ability to use both at, sort of in a way where you can run Postgres, start building microservices around it in the native Postgres language, while also continuing T-SQL and continuing to develop that. So I'm just going to show a very basic, again, this is probably pretty clear, but as you connect your application to the TDS endpoint, that's how SQL Server works today. Whereas if you're looking at Aurora, you're gonna have basically the same data stored. But if you were to do this this is an example of going without Babelfish. If you were to just translate, by hand, inserting some data to SQL Server, then saying, hey, I can just do this without Babelfish, I'll just go to plain Aurora, then you're going to notice something, which is that you start losing some of your correctness and things aren't quite as easy as they seem. So for example, for the money data type, if you were to insert that into SQL Server, well, that has 4 decimal precision. However, in Aurora, that has a 2 decimal precision because that runs on Postgres. The Postgres money type has 2 decimal precision. As you can see, this is going to cause a lot of problems, especially if you're rolling up data and things like that. And that's something that basically Babelfish will fix. If you're using Babelfish, the money data type, we created a special money data type, which is transparently there when you go through the TDS port. And the money data type in Babelfish is actually 4 decimals of precision. So what the lesson here is that by going through Babelfish, you don't need to worry about all the different data type differences between SQL Server and Aurora, right? You're just going to be able to use Babelfish and that precision will be the same. You won't have to worry about data loss. But it does go a little bit further than that. And this is something I alluded to a little bit earlier on. The actual transactional semantics in SQL Server and Postgres are different. And this is something that can really bite you when you do a native migration, and Babelfish helps a lot. So for example, if suppose we take a situation of a unique key. You have here table T1 and just takes just one column A, which is unique. If we insert 2 values, we insert 1, we insert 2, and then we insert 3. And what that's actually doing here is actually we're setting all rows to 3. Right? So it'll set the first one to 3, the second one to 3, and then because 3 exists already, that's not unique, it's going to cause a duplicate key insertion error. Now, what happens in SQL Server? Well, actually, it doesn't roll back everything. It doesn't, it actually will have the value 1 and 2 there, and then, it won't execute line 4, but you're going to actually have that 1 and 2 in the database, right? Now, Babelfish behaves the same way. If you execute this in Babelfish, it will keep the 1 and 2. We make sure we use the same transactional semantics when you go through the TDS port. But what were to happen in Postgres? Again, we're inserting 1, we're inserting 2, and then here, if you can see my mouse, then we're setting all values to 3, all rows to 3, and that's going to create the same error in Postgres. However, now Postgres rolls back the entire transaction, right? So this is one of those snags that happens when you migrate that you have to keep an eye out for. But again, if you use Babelfish, it maintains those transactional semantics. So even the rollback behavior will be the same with Babelfish as it is with SQL Server. So now that we've covered that, you understand how we go fairly deep into the SQL Server engine to really make sure that Babelfish behaves the same way, provides the same sort of results. And the goal here is just to make sure that your migrations happen faster. A big question is, well, how do we develop going forward? Again, I touched on this earlier, but you can develop new functionality in T-SQL using SQL Server drivers. And don't be shy about that. A lot of people say, hey, well, should we really be moving to Postgres? Again, it depends. If you have a huge monolithic app, and we see this very often, it's probably unrealistic to immediately rewrite everything and go new and start breaking that off into microservices off the bat. You're probably going to be in T-SQL land for quite some time, and you're free to do that. We encourage that you develop new functionality in Postgres, try to build them into a microservices architecture if you can. And then, in some cases, you're going to have a little bit of both. That's kind of the third part here. And again, avoid mixing too much. It's best to try to siphon things off into sort of microservices because of that rollback issue. Think about how something would behave if there's a trigger, for example, that's written in SQL Server, but then you execute it through the Postgres port, right? So you have to just watch out as you do that. And there's actually a document which we can provide you about, guidance when you're going through both protocols and what to watch for. But as a rule of thumb, just try to keep in mind that, watch out for triggers that might execute in a different language. And if you're just doing things like selects and inserts, that's not a problem as long as there's no triggers on those tables. Now, another advantage to Babelfish is that it's open source. I won't dwindle on this too long, but this really means that you're safe if ever you wanted to set up a development environment. You may have a multi-cloud approach and want to run Babelfish on other clouds. Whatever it is, it's a Apache 2.0 license, so there's no limitations. It's very flexible, like it's same as a MIT or similar to MIT license. You can even change the code for your purposes and so forth. And of course, if you want to contribute to the project, you're free to do that. Now, I want to cover a bit about the migration path here. What are we going to do in terms to migrate? What does that look like? Well, the first step isn't even running Babelfish. The first step is really just export your DDL, then run an assessment tool, and I'll talk about those. The more common one is called Compass, and I'll talk about that in a moment. But you run an assessment tool. That's just a command line tool, and that generates a report. That report is just an HTML report. I'm going to show you a screenshot of it, and that will tell you, how much Babelfish supports your app. In many cases, you'll have sufficient support. You just have to adjust that DDL a little bit. What does that mean? Well, maybe there isn't support for an optional parameter. Maybe you have a bit of XML, which, well, one day we hope to support it. Today we don't. So you might have to convert that XML into JSON, for example, because we do support JSON, and do a few adjustments there. Then you're just going to import that adjusted DDL into Babelfish with SSMS. Again, I want to emphasize there's no SCT conversion here. Babelfish natively supports the SQL Server DDLs. And finally, just import your data. Like after you've imported your DDL, which is your table structure and so forth, you're going to import your data. And just a hint there, you might want to start with just a small data set to test the app. You can import maybe 100 megabytes or a gigabyte or two of data and see how the app works. If it's looking great, then import the whole thing, right? Import it all. So for the migration assessment tool, just so you know, there are two options. One is an open source tool called Babelfish Compass. If you get your hands on this presentation, then you can download it. You can see there's just a GitHub download link in the presentation here, but you can even just search Google for Babelfish Compass and you'll get the link. The other is SCT. SCT does have a built-in assessment tool. However, I would say just it's handy because you probably already have SCT installed on some of your toolkits and things like that. If you have a computer that's used for conversions, you may have it already. But really, I'd recommend Compass. It's updated very regularly. It's contributed to by the community a little bit, at least with feedback, and it just it's really custom tailored to Babelfish. As you can see, the report here is very detailed and very easy to do. I have an example command line here at the bottom. Again, just one command line, that's all. There's no unusual dependencies. It's kind of just simple Java. You don't need the latest version of Java or anything to run it. So I want to also just emphasize, to avoid confusion, Babelfish isn't even needed at this stage. If you're just doing evaluations to see if Babelfish is for you, all you need is Compass and a DDL, which you can export from your existing app. So I'm going to talk briefly. I want to give some time for the rest of the presentation and questions. What does Babelfish support? Well, it supports a lot. It doesn't support 100% of the SQL Server dialect, but it definitely supports a lot. Triggers and stored procedures, nested transactions, table valued functions. You can take a look yourself. Also case insensitivity, and also we map many of the errors, hundreds of errors, so that way your control flow, your error catching try catch will work. Now, here are some potential blockers. For example, multiple active result sets. Note we do support multiple result sets, but not multiple active result sets. Multiple active result sets is when things sort of change and update in real time, whereas multiple result sets is just getting multiple result sets that we support. But things like that, database mail, geospatial, we really prefer to use PostGIS or the SQL, the Postgres equivalent, and the CLR, and also column store. Again, we don't support that today. To keep in mind for things like SSRS, you're probably looking at this list. Well, SSRS, SSIS, and SSIS, I'd say speak to your solutions architect about that. We support quite a few use cases there, because you can use Postgres as a target. So you may be in luck there, but it's definitely limited. Today we don't support linked servers. It's definitely something we're thinking about, but that's something you should factor in. And then again, XML, one thing you might want to do is convert your XML to JSON, which we do support. But that's something that you're going to have to work around with Babelfish today. There's always improvements in terms of the bulk insert API, but again, that's something we see a lot. And if your app is fully dependent on that with a lot of workflows around bulk insert, then again, you'll have to just think of something else. You can use the Postgres copy command or talk to your SA and they can get a specialist team to look at it. Sometimes bulk insert is used for speed and sometimes bulk insert is used for convenience. And depending on that, you might want to choose different Postgres equivalent tools to get the job done. In terms of what you're going to do, the best tool I'd say is SSMS. Again, you can use what you use today, especially I'm going to talk about some of the support of that going forward, but you can just log in with that. Make sure that you use, again, the latest version of Babelfish because we're rapidly adding SSMS support to the product. Then there's SQL CMD. And then aside from that, I have to say that your mileage may vary. Other tools may or may not be supported. You can try them out, but because we do a partial implementation of the SQL Server dialect, not every single system stored procedure is going to be supported, and especially some of these client tools that use, less common system stored procedures, they may fail or they may give you kind of limited support. So just keep that in mind. Now I'm just going to take a moment to talk about what's new. So with the new version, actually the latest version is 1.3, which I recommend you use. That's going to be Aurora 13.7, and you're going to get a lot of things with the latest version: grant revoke, row version support, easier SSMS logins. In the past, if you choose an older version, you may have noticed you require a workaround, but we're eliminating that. And the last thing I want to end is very shortly, I can't give you a date, but it's definitely something that you're going to see soon. You're going to see Aurora 14 released. And when you do see that, I would recommend that because we add a lot of really interesting features. That's going to be Babelfish 2.1. And Babelfish 2.1 will have a lot of SSMS support. It's just going to make you a lot more agile. You can drill down to the column level and check out your tables and things like that. And also we're going to have role support, just a lot of really good, great goodies that we're adding to Babelfish 2.1. So if you do see Aurora Postgres 14, or you finally do get that awesome announcement that Postgres 14 is out, then I would definitely opt for that version with Babelfish. And that's it. I'm now going to pass it on to the next presenter and take questions.
Thanks, Simon. Yeah, I'm going to go ahead and take over as a presenter to show a quick demo. And to all the participants, thank you so much for staying back. I know we are slightly late than what we planned, but hopefully we'll make it worth your time. So I'm going to go ahead and show a demo of working with Babelfish for Aurora Postgres. But if you have questions, feel free to drop those questions in the Q&A box, and team, including Simon, can try to answer those questions. Cool. So how do you create a Babelfish for Aurora Postgres instance? It's not very different from creating any other RDS instance. In fact, it's just exactly the same. You come to RDS console, or you click on Create Database button, and you will see a screen similar to the ones that we saw for RDS SQL Server. But for Babelfish for Aurora Postgres, you have to select Amazon Aurora because it is a feature of Amazon Aurora Postgres. And with Amazon Aurora selected, go ahead and choose Amazon Aurora Postgres Compatibility Edition from the list of editions. Make sure that you choose version 13.4 or above. In my case, I'm going with version 13.6. And what you would see is I'm quickly just scrolling down. There are a few options which are very similar to what you saw with RDS SQL Server, like production and dev test, cluster identifier, and credential, etc. I think the first interesting thing to notice here is with the Aurora Postgres, we support serverless way of running your server, which means your compute and storage can be decoupled. Unlike what you see with something like SQL Server, where you have to choose your instance size, Aurora Postgres can actually scale the compute, and the unit of scale is called as Aurora capacity unit. So you can start with something as small as, in this case, I've selected 8, but you can Aurora is going to auto scale based on the load. So that's one thing. Another is if I scroll down, again, connectivity part and everything is similar to what we saw for RDS SQL Server, so not very different from that perspective. One thing that you will have to keep in mind is make sure that you select turn on Babelfish option, because if you will not turn on this option, Babelfish will not be enabled by default. So make sure you select that one. And let me go to additional configuration. And yeah, another thing to notice here is, which is specific to Babelfish that you have to keep in mind is, you can create a Babelfish for Aurora Postgres instance with single database mode or multiple database mode. If you plan to use your Babelfish instance for more than one database, like a typical SQL Server instance, you may like to choose multiple databases. Single database may not meet all of your requirement. Then collation name, the port number on which Babelfish endpoint is going to listen, and then database parameter group. If you have to optionally add more parameters later point in time, it is decoupled from the setup in the form of parameter groups. That's pretty much it. I mean, there are a lot of things which are standard for RDS, nothing specific to Babelfish and Aurora. But with these settings in place, you can go ahead and click on create your database. And once your instance is provisioned, I'm going to click on cancel and go back to this instance. So here is my Babelfish instance that I have created. It has one writer instance and a reader instance, the ones that I can connect with. And if I connect on my Aurora Postgres instance name, under connectivity and security, you will see these options. I have my reader endpoint and writer endpoint. So, and it's a same endpoint both for Babelfish as well as for Aurora per se. So if you want to work with native functionality of Aurora, it's the same endpoint. Only difference is the port numbers on which the Babelfish listener is going to communicate versus Aurora native functionality. Once you have the endpoint, you can copy endpoint, you go to your SQL Server Management Studio, and you can do query connection. In fact, I'm going to do a new query if I can. Connection, okay, change connection. And I'm going to point to my Babelfish cluster here, which in this case is the one which says Babelfish in its name, Runit V Babelfish 1360. And since by default it supports SQL authentication, I'm going to go ahead, provide the credentials, and connect to my instance. Now, what you see here is I'm currently connected to a Babelfish instance, an Aurora Postgres instance, communicating over TDS, understanding my T-SQL, which means I can now run T-SQL commands directly. I think I had a couple of commands which I want to use. Yeah, let me just copy everything from here and move it to this new query that I just, which means if I run select at version, what you will see is it's telling me that I'm now connected to an Aurora for Babelfish for Aurora Postgres. So if I zoom in, you see the version is Babelfish for Aurora Postgres with SQL Server compatibility, I can run some of the supported DMVs, like for example, sysdatabases. If I run that, it is giving me a list of databases, at least the way it looks like. I can look at existing connections. So if I run DMExec connections, I can even see the incoming connections which are currently enabled for this instance or which are currently connected to this instance. Similarly, now let's take a scenario. I have this local SQL Server instance which had this database called as Gadgets Online. And what I did is I exported the Gadgets Online database. I think this was the one, DDL. And as Simon mentioned, you can use a tool called Compass. So what I did is I ran Compass around against the DDL for my Gadgets Online database. And I got a report back saying that there are a few things in this database which may not be currently supported as it is for Babelfish. So here's the assessment report. And if I scroll down, you see it tells me here's a list of features which are not supported, few things which require manual review, few things which are review for performance, so on and so forth. So the first thing to notice here is this telling me that in my DDL, there are 3 occurrences of alter table check constraint, which is currently not supported, which means if I have to run the same T-SQL against the Babelfish endpoint, I have to make sure that this has been taken care of, right? Besides this, I think I'm pretty good. I'm getting some information about semantics. For example, if I just can zoom in, it says cluster constraint are currently not supported. This constraint, the constraint will be created as if non-clustered was specified. So it is going to make some assumptions on your behalf, but it's worth looking at the whole DDL. Now, what I did is I took this DDL and removed those alter commands and adjusted for Babelfish, making sure that all the recommendations that were given by Compass have been taken into account. And here's that T-SQL. So what I did is I ran this whole T-SQL as it is against the Babelfish endpoint. And what I got in turn is a database called as Gadgets Online DB, smaller decimal. I run this. I am now connected to this database running on Babelfish for Aurora Postgres. These were all the tables which my database had. Like if I can expand it here locally, these were all the tables I had. Some cards, categories, order details, etc. And if I select this and execute, all these tables got created. And since my DDL also had insert commands, all of my data also got inserted, which means the same T-SQL after running Compass and making corresponding changes, I was able to move or migrate my database along with data to Babelfish endpoint. Now, what that means is, here is my application, a sample application, which is an e-commerce application, which uses the Gadgets Online database. The application is called Gadgets Online. It is showing me list of products coming from database, and it is currently using my local SQL Server instance. Now, what I can do is, since Babelfish speaks T-SQL programming language, and it speaks TDS protocol, what I should be able to do is, rather than using the local instance of SQL Server, which is this one, I should be able to comment this line and uncomment this line for Babelfish connection string, and should be able to point my connection string to Babelfish endpoint. Let me just move it on the side, make sure I put in the correct username and password real quick. I am updating the connection string, putting in the right credential. And I think I've got the credentials right, hopefully. And now let me just bring it back over on this side. And now I'm connected to my Babelfish endpoint. And let me go ahead and run the same application. And if everything goes fine, only by changing the connection string, in this case, it was a relatively simpler application. So I did not have to make a lot of code changes. For your application, you might have to make some code changes. In fact, the biggest code change I had to make was this application uses entity framework. So what I did is I influenced entity framework to not try to recreate the database. So what I told is that don't try to initialize the database. For that, I commented this line to this line. This was pretty much the only code change I had to make. And right now it's still spinning. Yeah, I hope I've got everything right. Yeah, there you go. Now I have this application which was communicating with local SQL Server instance, but after migrating my database and after making corresponding changes in my DDL, I can make my application talk to Babelfish without changing a lot of code. My application still is getting an experience it was getting from SQL Server. It is still running, it's communicating to the Babelfish endpoint using the .NET provider for SQL Server. And there's no change in the functionality. I can see the products, I can navigate the application, I can make changes. Now, what this does is it lets me migrate from SQL Server to Aurora Postgres a lot more quickly. Now I can start maybe taking out the code which has dependency on T-SQL and start leveraging native Aurora Postgres functionality and start leveraging perhaps the Aurora Postgres provider for .NET or Postgres provider for .NET. And over the period of time, I could decouple my application totally from everything and anything that has to do with SQL Server and start leveraging the Postgres native functionality. So that was a demo. Let me take a pause and look at any questions that we may have. Yeah, while I'm going to go ahead and look at the questions as well, before I forget, one last thing I want to share is, again, thank you so much. I know we are perhaps like 25 minutes over the stipulated time, so everybody who has stayed back, really appreciate it. I'm going to go ahead and start answering to the questions. So if you have a question and if you can stay back for a minute, please do so. Otherwise, the recording of this whole webinar will be available to all the participants within the next 2 weeks or so. After this session ends, you will get a survey to take your feedback, and your feedback is very important to us. So please do share the feedback. On top of it, if you think you found something interesting today and you would like to maybe dive deeper on those things specifically to your use case, do reach out to us. This is our email address. You can write an email to us, or you can fill in the online web contact form, and one of us will be in touch with you. And we keep on doing sessions like this. This is just SQL Server, but we're going to do more sessions like this in the future. If you want to stay in touch with what's coming up, do follow us on Twitter. Our team is on Twitter at .NET on AWS. Though it says .NET on AWS, anything with Microsoft Technologies is published on this Twitter handle. So you can follow us there and keep up to date on what is coming up in terms of new sessions. Yeah, that was the presentation today. Thank you so much for your time. Again, if you have questions and you're staying back, I'm going to stop presenting and start answering some of those questions now. Thank you.
I can actually take the question. What is the performance hit on Babelfish, if any? If now's the time to start the questions.
Oh yeah, sure.
Great. Okay, so theoretically, there's no hit because there's no additional layer. I mean, again, you have to have something that interprets your SQL code into, the query processor. Whether you do that through the Postgres PG-SQL side, using the Postgres dialect or the SQL Server dialect. Again, we're not doing, like string translation or anything like that. You go direct to the engine. However, there's a few things to keep in mind. The first is that, remember, you're using the Postgres engine, not the SQL Server engine. Now, these are very different engines. There's some things that run faster on Postgres. There are some things that run faster on the SQL Server engine. So if you take just a query and run it on SQL Server and then you run on Postgres, odds are good that you're going to have very different performance and a very different performance profile. It also is likely that you might, to get the optimal performance, you might need to structure your query differently, because again, Postgres is going to, in some case, make implicit conversions where SQL Server might not, and implicit conversions take up a lot of, just take up a lot of extra cycles. So in some, keep in mind that you're really running the Postgres engine. So the question is there a difference in the speed between the Postgres engine and Babelfish? And I'd say theoretically, no. Practically speaking, of course, we're implementing a new interpretation layer, and it's a fairly new one. There could be some areas where you see, performance a little bit less by going through the Babelfish side rather than the direct Postgres side, right? Writing it in native Postgres code. That code has been optimized for, over 15 years. Going through the Babelfish side, you might see some functions. For example, we found some slowness in some date functions just because, Babelfish is a slightly newer product. And so you might see a slightly softer area in performance in some rare cases. If you find those, I'd recommend reaching out to the Babelfish specialist team, and we'll work you through that. It is pretty common that, in fact, when people say that, it's often simply because they didn't really optimize for the Postgres engine, and we're very happy to help with that. Just keep in mind things like, again, I'd say that implicit conversions, just the way you structure your query, should be done in the Postgres way. And a good way to see that, by the way, is there's something in Postgres called auto-explain, and if you use auto-explain, that just sort of dumps all the query details into the Postgres log that you can see kind of how it's executed, and that'll really help, especially with things like implicit conversions. That way you can see how to structure your query to make it as fast as possible.
Awesome. Thanks, Simon. We got one more question, and I think this is something that I promise I'm going to show that it's just not create tables. Other T-SQL constructs which are currently supported on Postgres, like for example, if you want to create a stored procedure and just to confirm I am connected to Babelfish, yeah, so I can create procedure, and you see the command got completed, and I can call this SP just the way I would call SP in native SQL Server, and you would see the output coming back in as well. So if a construct is supported on Babelfish, you should be able to use that T-SQL as it is. Again, as Simon mentioned, your mileage may vary depending upon how complex your T-SQL code is and whether we support all those features. But the very good place to start is dump all your DDL and run the Babelfish Compass tool, which is available at no additional cost. It's available on GitHub. You can download this PAT file and just run it, and it will give you a report that in your database, what are the current objects, what are the current T-SQL construct which can run against Babelfish as it is. Cool. If no other questions,
We have one
then
last question, Runit, and then we can wrap up. Do you offer encrypted connection on Babelfish port?
good question. I think we do. I may have.
What was the question?
So the question is, do we support encrypted connections for
Yes.
Babelfish endpoint? Okay,
Yeah, we do. Yes.
Awesome.
Yes.
Thanks.
All right, so I think with that, we can wrap up our webinar. So thank you everyone for attending the SQL Server Database Modernization webinar. Thank you for your participation, a lot of great questions. And as Runit mentioned, we would be sending you the recording soon after the webinar, as well as a survey. So we appreciate your feedback on the survey, and we thank you for attending. Have a great rest of your day. Thank you.
Thank you all.